Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to share the introduction to statistical quality control from a book which actually I used a few years back. This is one of the good books on quality control, Douglas Montgomery. So probably if you want to have a look at this book, it's very technical bias, very engineering bias. But that's where actually statistical quality control started. So we look from Montgomery's perspective. He's a statistician, engineer. So, so this is just an introduction of quality, and particularly the need for quality improvement in today's modern business environment. So we will look at the definition, simple definition of quality improvement, and we look at the dimensions of quality briefly. And probably I need to break this into one or two videos in order for me to complete. It's quite lengthy. Right. So quality has been defined in many ways, and one of the most important way of visualizing quality is through the viewing it from the 8 dimensions of quality. It was proposed by David Gavin. If you care to, refer to David Gavin, he said that quality can be broken down into this dimension, which is performance, reliability, durability, and so on, serviceability. Because quality is not only just about product performance or the ability for it to meet its function. Performance is very straightforward. For example, if I say that if I buy a new car, if it promised to be able to accelerate from 0 to 100 kilometers an hour in 12 seconds, in 50 seconds. So that's the promise, the oil consumption, and so on. Reliability, when we talk about reliability, it's quality against time. We talk about mean time to failure, mean time between failures, the probability of it failing after a certain number of usage, like our fluorescence light. The fluorescence light can last us, 1,000 hours and so on. Or a tire will last you until 60,000 kilometers of normal driving. Durability, how long, how good in terms of the product to withstand shocks, harsh environments, durable. Serviceability, the ability for the product to be easily serviced. That is also part of the quality dimensions. Because David Gavin, I think he studied the air conditioner manufacturers. He compared between the American air conditioners manufacturers against American. Found that Japanese products are easy to assemble and disassemble for maintenance. So it comes under maintainability. Aesthetics, those are things related to design, the beauty of the product. If you look at the car, in terms of the design, the color, the shape, and so on, and our features. So this determines, the dimensions of quality, and of course there are also the dimensions of service quality as suggested by Parasuraman, so you can refer to that. And from a definition of traditional definition of quality, which is quality means fitness for use, and when we buy a product, whether it fits the function that it's designed for, right? So it comes from quality of design. That means when we design the product, design the computer, for example, Okay, it meets all our requirements and it doesn't fail easily. Uh, and of course, it depends on the quality of conformance as well. That means when we produce the product, we must make sure that all the specifications, all the physical requirements are being met, and it can be done to inspection and measurement. So this is the typical way that we actually view quality. As long as it fits the purpose, fits the function, we are happy. You know, very simple example is when you compare watches. You know, a Seiko watch versus a Tag Heuer. You know, it's if the Tag Heuer or the Rolex watch actually have um, problems, you know, it failed to give the correct time. It runs away from its accuracy. So it's not fit for use, you know, it has defects compared to, for example, a normal Seiko watch. So fit for use is different from grades. Grades, you know, Rolex are of a higher grade for certain market segment. It's a luxury product. Mercedes is targeted for higher income group, and but Mercedes that stalls in the highway is defective. Okay, a new, especially a new Mercedes or new BMW, if it fails in the market, it doesn't have the, you know, it fails the customer, right? And the modern definition of quality, according to Montgomery, is that quality is inversely proportional to variability, meaning that, you know, the quality of a product depends on how much variability, or how much it deviates from its target value, or its you know, intended value, or of especially technical means, in technical manner. This can be illustrated. This is a very classical example in which the comparison was made between the transmission of automobile between the United States, well, manufacturers from US and manufacturers in Japan, the warranty costs, and you can see here it's like 1/3 of US. It's classic, it's an old study. However, because it illustrates that this is the target value, some target value of a certain dimension, physical dimension, and this is the variation. This is the normal distribution for Japanese products. This is the normal distribution for US products. The upper spec limit and the lower spec limit. So you can see the variability. Variability is given, shown by the standard deviation, sigma. Okay, if the sigma is big, then you have broader. If the sigma value is smaller, you will have a smaller value. So we have to look at all products, how much variability that it actually exists. So the lower the variability, the lesser the, you know, the differences between the values. They're getting much more consistent. That means these Japanese products are much more consistent. These are the reasons why Japanese products last longer, are more reliable than, you know, products from US or even from Europe. And we have to view from the perspective that quality improvement must be done, and it is done through the reduction of variability in processes and products. Imagine your manufacturing processes, your cutting process, your bending, your grinding, or whatever, you know, in electrical or in medical base. Processes will have variability in terms of the raw material that you purchase from suppliers. variability in terms of the human resource, the workers that you have, the variability in terms of their skills. So if we can reduce the variability of all these sources, man, method, material, machine, you will be able to produce consistent product. And all this can be measured and can be defined and model using statistics. Because statistics is the knowledge behind understanding variation. Okay, so the quality improvement, the transmission example shown earlier is illustrate the utility of this definition. That means if we can reduce variability, we can actually achieve higher quality product, best quality improvement. Another way of equivalent definition is that quality improvement is the elimination of waste, particularly useful in service or transactional business. So if we can reduce waste, and it's very much related to another concept, which is actually lean. You can call it lean manufacturing, you can call it lean systems, or it was originally developed by Toyota production system. The elimination of waste is actually trying to make the process much more efficient. So basically, quality will only be improved by a systematic and consistent way of looking at all processes with the intention of reducing waste, the intention of finding or reducing the variation. So every product possesses these elements that can be described according to consumer, and the consumer will look it as quality, and these are known as quality characteristics. Sometimes it's called as CTQ. I think some of you probably have seen CTQ, so critical to quality characteristics. And there are several types of these quality characteristics, particularly within the product that we produce or manufactured products. Physical characteristics, sensory characteristics, and time orientation. We engineers, we like to, I'm an engineer, we like to look products from, things that we can measure: length, weight, viscosity, their surface roughness, and so on. Taste, we can measure quality, we can taste. For example, that's why there are tea, they produce tea, there are tasters, they produce all these food products, the tasters, the appearance, the color. So all this constitutes measurable quality characteristics. Measurable, I mean, there are units that you can measure, or even, for example, you talk about taste. You can give a ranking of 1 to 5, you can give a Likert scale, so this still measure. Appearance. And time orientation, we talk about reliability, durability, serviceability. Again, I repeat, mean time to failure, mean time between failures, all this can be measured. There are reliability models, there are Weibull distribution, there are exponential distribution that actually you can measure reliability. So since variability can only be measured or described in statistical terms, therefore, statistical methods is important for quality improvement. That's why I always emphasize that if you want to improve quality, you must look it from a statistical perspective. And there are many knowledge areas, there are many tools that can actually help us. And typically when you are dealing with statistics, you need data. Okay, so we don't have to talk about big data. We need, if we have a small number of data, we need to manage the small data. But basically, we need data to to understand the issues, the problem, and data basically it's attributes or variable data, at least within the quality control or quality engineering perspective. So statistical based quality engineering tools for dealing with these two types of data. There are tools for all these. And in quality also, we need to understand there are these terminologies involved, those specification, application, target value. Okay, target value. So if you draw a normal distribution, so this is normally the nominal or the target, and you have some specification in it, upper specification, lower specification. Within the control charts, there are other terminologies like upper control, normal, lower control. And we need to understand the terminology of defective or non-conforming product, the term defect or non-conformity. For example, the screen of the computer screen has scratch. That scratch is a defect. But when you say about defective, defective means the, for example, the solid state drive is kaput. It's not no more functioning. It's damaged. That's defective, which result into the product not be able to be running. But a scratch won't affect the running of the computer. It's just minor. Well, it's not minor if it is new, but you go along, you can manage and you can still use it if the pen has scratch. So not all products containing a defect are necessarily defective. So if you look at the history of quality improvement, or this is actually the quality movement development, historical, it has largely been very industry-based and engineering-based, starting from Eli Whitney, during the Industrial Revolution, Frederick Taylor, the father of industrial engineering or scientific management. Myself coming from the industrial engineering fraternity, so this is how the industrial engineering view a lot of improvements can be done, quality improvement, process improvement, from the perspective of motion and time study, waste reduction. And the development, particularly I would like to just emphasize Shuhat, economic control of quality of manufactured products. Those who are in the quality area, if you do not know this book, then you need to do some revision. Okay, economic control of quality of manufactured product was the first book published in 1931 to propose the concept of control charts. Okay. And later on, the development of Royal Statistical Society in UK, Deming invites Stuart. So Deming is also one of the gurus in quality, and the name Joran, and then Genichi Taguchi began study and application of experimental design, particularly Taguchi methods, and it was proven very, very successful by the Japanese to really reduce variation and to do it very early in the process. That means during the design stage, they can actually identify which parameters will affect, the product performance. And in the development of a Toyota production system, which is actually the lead, helps to, integrate further the quality field. And it's a lot. Okay, you can read about this, all this, the quality control handbook, technometrics. So it has matured. I think the field has really matured. And if you look at this, there's Box and Hunter, factorial design of experiments, which is popular to use to optimize processes used in electronic, aerospace, semiconductor, and automotive industries. And today we are trying to promote a robust quality engineering technique in Malaysia, but it's very difficult because not many companies are willing to invest in, or willing to learn the difficult things about, orthogonal array, what we call signal to noise ratio for Taguchi methods. So those are things that probably Malaysian companies should embark on and try to implement. Motorola Six Sigma. Six Sigma is nothing but, you know, the extension of statistical techniques. Only that it is being structured into a formalized program for quality projects, quality improvement, and how it impacts into business. You know, how can reduce costs by using or by employing a Six Sigma. So this is how we should view all processes. Process, there will be inputs, some are controllable, some are uncontrollable, and you produce your products. So there are quality characteristics in the combination of these inputs that you monitor. For example, viscosity is combination of the chemicals that you use in the process, or even the hardness, you know, for product that you actually casting, you know, it's depends on all the variation that exists in the process. So products must be monitored, measured, evaluate, monitored, and controlled. So that's the purpose. You know, if we can monitor our inputs and outputs, and we can look it from a statistical perspective, we can do a lot of improvement, understanding from a statistical perspective. So the statistical methods, these are some of them. The main one, SPC, control charts, design experiments. We in Quality Circle, we have said this is an online technique. That means you collect the data in the process, and you try to eliminate assignable causes. You reduce variability by eliminating assignable causes. But if you do it much earlier, or if you do it trying to optimize, this is offline technique. That means you do design or experiments. You try to discover the key factors that influence process performance. And you decide the parameter, whether you should, you know, the temperature, for example, is it better at the lower or a higher level? Certain material A, is it better at a higher, meaning more of that content, ingredient, or lesser? So you optimize all the parameters, and you decide on the combination of these parameters. And also, there is this acceptance sampling. For example, Ministry Standard 105E, 105D, okay, E105E, which is actually acceptance sampling schemes which are used to decide, to make decisions of whether we should accept the lot or reject the lots that we are doing sampling inspection. Okay, so there are schemes, inspection schemes for that. And all these are actually derived statistically, looking at the probability of occurrence and trying to make decisions based on that. Okay. So this is a Shuhat. Shuhat is trained in engineering. He was the first person to actually develop control chart. So we should be thankful to him for giving us this knowledge. This is a schematic, diagram showing the factorial design for processes, and we try to optimize. Like I mentioned just now, if we have a two-factor variable in the process, you do experiments, high-low, and you try to find the best combination. 3 factors, 2 to the power of 3, you need 8 experiments. Okay, 2 factors, you need 4 experiments. So the whole idea is, can we model the process and try to find the combination of parameters that best fit, and you can be able to achieve high quality. Acceptance sampling, this is what schematically process, you do inspection, and for outgoing inspection, process inspection. So you can use, you can employ acceptance sampling here. If it is accepted, then you ship out. That means it's used during outgoing. Or you can use acceptance sampling during receiving inspection. Lots which are you receive, you do inspection. Then if it is okay, you pass on to the customer or use it in the production line. Okay. Or so you can also, this is a typical disposition of lots. That means you do inspection. So the rejected lots, either you scrap it or you rework it. Those accepted will be shipped or be used. So acceptance samplings can be used in many situations. It's widely used. In formerly, I've seen this application in electronic industry. Now, so we move on to management aspects of quality improvement. So there's a lot of technical things that are involved in trying to ascertain quality achievement. Technically, a lot of them. SPC, Statistical Process Control. Well, we have other tools like FMEA, Failure Mode Effect Analysis. We have QFD. I have a video on that. QFD. I have a video on quality cost. So there are many tools that is important. But of course, organization, you have to look at your level to decide which tools are important to you. And of course, the complexity of your products that you produce. So that will determine which tool. There are research being done on the tools that can be used in order to for your improvement projects. And I forgot to mention there's also the 7 basic tools: Pareto diagram, histogram, cause and effect diagram. So those are also 7 tools of quality improvement. Now, the effective management of quality is also important. That's why in quality management or quality field, there's one is the the engineering and the technical part. One is the management, and it supports each other. So effective management of quality requires execution of 3 activities: quality planning, quality assurance, and quality improvement. So quality planning is, simply put, is you have to plan for quality. You have to decide where you're going to do inspection. You have to decide the human resource training. So it is it's put at a strategic level, okay, strategic quality plan that the company level decide, involve identifying customers and identifying their needs. So it says here, identify customers, identify needs, and you plan how the product is going to be produced, right from a design until what they call sales and service. Okay. Assurance is another part of quality, particularly with respect to the system. Okay, the documentation, it is set activities that ensure the quality of products are properly maintained and supplier and customers issues are properly resolved. So basically, it's about having a system, and the documentation of the quality system is important, consisting of policy, procedures, work instruction, and specifications and records. So this was formerly the ISO 9000 fundamental, the basic premise of ISO 9000. It is a quality system. It requires the company to set up clear policies, clear quality goals, and outlining all the necessary procedures, specification procedures, design procedures, manufacturing procedures, and cascading down to work instructions. If you've seen this pyramid hierarchy of what we call quality system. This is record, this is work instruction, this is procedure, and on top of this is policy, which you put it into a quality manual. I think many of you probably have seen this in quality ISO 9000 system. Basically, what quality assurance does is actually to make sure that you have the system in place, and you don't have to let customers, for example, I'm a customer, I want to know how you produce the car or your product, or even for that matter in higher education. How do lecturers teach? How do you actually do the marking? How do you actually set the grades? Is there continuous effort to improve the skills of the lecturer, improve the curriculum? So you don't want parents or stakeholders to actually every time an audit come and audit and check, I want to see how you produce the car. I want to see how you produce the cake. So assurance means providing confidence to customers that your process has the ability to meet whatever requirements That means the process, if I'm producing graduates, it is a quality graduate that will be able to perform, their jobs effectively, efficiently, with the knowledge in the real world. Okay, a car can perform its function, so you don't have to worry. You don't have to. The customers don't have to come and check all the equipment, all the records. So it's providing confidence to whoever has stake or have some say, because you buy the products, you'll be rest assured, everything is in place. Right? Let the experts deal with the problems and solve that. Okay. And quality control improvement involve a set of activities to ensure that the products meet requirements and improve on a continuous basis. So since variability is the major source of poor error, including, so you must use the quality control techniques such as SPC, design experiments, to actually do the improvement and the monitoring and the control purpose. Okay. And oftentimes, the quality improvement is done on a project-to-project basis. So many companies, that's why we see previously there are, QCC circles, quality control circles, or even today QIT, quality improvement team. So the main idea is to get people involved, workers involved, to give ideas and do improvement activities, so that at the end of the day, the customers will be satisfied. The problems that being highlighted by customers are being resolved, addressed, solved. So it's a continuous journey. You cannot achieve perfection without any effort. So quality cannot be achieved. Product quality cannot be achieved by chance. No way. No way you can achieve quality just by dreaming and hoping that the process will be good. Okay. So I admire Deming, Dr. Edward Deming, the quality guru for total quality management. He died at the age of 93, and right until before he died, he was still giving consultancy services projects, or giving talks to companies, organizations in the United States, and he's a strong believer of the responsibility of management, quality management. But he's an engineer, so he says that you must use statistical tools, but at the same time, management must take the responsibility to put quality at the strategic level. Quality shouldn't be put at an operational level. And he was sent to Japan. He helped Japan to improve their product quality. Was invited by the Japanese Union for Scientists and Engineers, JUSE, okay, to lecture on SPC. And Japanese adopted his thinking, his philosophy, and he stressed continual, never-ending improvement. Right, he lived until 1993. So this is what you should all understand. 14 points by Deming. Create consistency of purpose towards improvement. This is for management. It's not for workers. His 14 points is directed to management and the practice of awarding business based on price alone. Many of us, many organizations call up tenders and award tenders based on price. No, we should be basing on quality, performance. Poor suppliers, poor service providers must not be given award for business. If we keep on giving business to low performance and based on price alone, we will face difficulty. That's what we are facing today. Okay, institute training, improve constantly forever system of production. So these are very strong statements that if you really need it, read and understand, you'll be able to improve your organization. Eliminate slogans, no need slogans. Okay? Eliminate work standards. So he doesn't believe in performance appraisal, management by objective. Because management by objective, as you state your objective at the end of the year, I'm going to do these 5 jobs, 5 things, I achieve these 5. I'm going to publish this number of X papers in X journals. You set a low target, you can achieve it. That's why, it's not surprising after a few years of implementing a certain what you call performance management system criteria, you see everyone getting 100% marks. That is, it's not surprising, because you set standards and human beings will be able to circumvent or manipulate or whatever what you want to call it. Okay, move around and work around those obstacles. Put everyone to work. Teamwork. This is a transformation actually. Transformation for the organization to become excellent, to become a quality organization. Excellence in everything, because quality cannot be achieved only by QC alone. QC cannot achieve quality. Quality can be achieved by good marketing program, good marketing officers. Quality can be achieved by good design, good purchasing, good production, good tooling, good processes, everything good. Then only you achieve quality. If not, very difficult. And also, I think it's very important to mention his diseases, emphasis on short-term profit. So these are, things which are happening in many organizations right until today. Mobility of management. Management keep on chasing for new positions in different organizations. This was predominantly happening in the US, in the States. Running a company on visible figures only, quality financial reports only, without looking at the long-term financial strength. Okay, excessive cost of warranty. So these are opportunities for improvement if we start understanding this. And PDCA. Those who are in the quality field will definitely know what PDCA is. PDCA is have a project plan a change or experiment. Have an experiment project. Do the project. Check it out, whether, study and analyze the results, what was learned and whether it's effective or not, then act upon it, PDCA. If you continue doing this PDCA, it's like a level. You have your first project, PDCA. You move up, PDCA. So this is called level up, okay? And you have to put wedge here. You have to put some stopper so that it doesn't slide down. So this idea of Schwartz cycle, whereby everything must be looked from the PDCA perspective. And these are obstacles, for success. The belief that automation, computers will solve problems. I don't think all automation and all computers automating an inefficient manual process doesn't improve the process. For example, we have this system in which we fill up these forms, and these forms will have this information, and you automate those forms into the database system. So without first actually analyzing, because an industrial engineer will look at the processes and try to optimize, make it, whether this information is redundant, is needed, So you improve the manual process first, eliminate all the problems, all the redundancies. Then only you automate, or you make it automatic. Okay, right. And Duran trilogy. So I think we'll stop sharing now. Quite long. I hope I will continue the next time, because I'm very passionate about quality, and I know many companies are struggling to. I'm not saying it's easy. I'm saying that if you have a clear understanding and clear direction, you will be able to achieve your goals. Thank you very much for attention. Assalamualaikum warahmatullahi wabarakatuh.